Hello, this is a lecture based on block diagram reduction techniques. In the previous lecture I have covered theory, all the 10 rules. There are 10 rules. Now in this lecture I solve the problems based on block diagram reduction. The first problem is question: find transfer function TF. Find transfer function for a below block diagram. For a below block diagram. The block diagram he has given the block diagram. G1 and G2 and summing point G4. And then out C of S. And here there is G3 here plus, here also plus, here also plus, and one more here minus, and feedback element, that is H2. So feedback. And H1 here minus, here one more H1. And then here it's input R of S, and here minus, that is nothing is there means 1. There is nothing is there means 1. This is the given block diagram. Here single input, single output is called SISO, single input and single output problem. Some problem are single input, multiple output, or multiple input, multiple output. Some are multiple input and single output. So here you see the first, these two are in series, but there is a take-up point. So I want to multiply these two. I am supposed to apply first rule. G1 and G2 are in series, but I have to shift this take-up point where this side. If I shift this side, then automatically what happens? These two become series. So now here, which signal is going now? G1 is going here. G1, whatever the X is there, suppose X, I will take one signal before here. Okay, here G1X is going. Only one step I will take before. Okay. So G1X, whatever the X, multiply this, G1X is going to G3. Now if I shift this, so now G1 and G2, now I am shifting here. So here G3. Now what I am getting here? Here G1X, and here I am getting what? G1, G2X. Here I am getting G1, G2X. So here G1, G2X. But I want G1X only to input to the G3. Input to the G3, I want G1X only. G2 is unnecessarily, G2 is coming to this side. So that what I will do, I have to divide G2 here. So definitely the input becomes what? Whenever there is an input G1, G2, but output is now G1, G3X. Here also the output becomes what? G2, G2 cancel, G1, G3X, same output here and here. Only you have to divide by G2 here, because you are shifting the take-up point from this to this side. This is the modification, and this is a plus, and G4 and what C of S, and and here R of S, and here minus, here also minus, this is H2, and after G2 I am getting, okay, after G2 I am getting, I can show this is this side, no issue, and here there is a one feedback, and here G4, this is minus H1. I hope you understood here. Here I took X G1, G1 X is going, and from G3 G1 X, G1 G3 X. Suppose if I shift here, the output should be remain same, but I am getting output G1 G2 X into G3. Unnecessarily I am getting G2, here no G2 here, so that I will divide by G2. Now these two blocks are in series, next these two I can multiply, these two blocks are in series. So now G1 G2 G1 G2, and here and minus H2, and from here is nothing but, here nothing is there means what? 1, here nothing is there, 1, and here G3 divided by G2, and here there is a plus, here this is a minus, and here that is R of S plus, and here minus, and here in this case you see here this is a minor feedback loop, this is a minor feedback loop, so that this value becomes how much? It's a minor feedback loop, so that this value becomes G4 feed forward divided by 1 minus is there plus G4 H1. So C of S. So this summing point is not vanishing because here already inputs are there. Now I applied two rules. These two are in series and this is a minor feedback loop. Correct. Next rule. Next rule. Now this is also minor feedback loop. This is also minor feedback loop, and these two are in series. These two are in series. I'll apply two rules at a time. This is a minor feedback loop, so that G1 G2 divided by 1 plus G1 G2 H2, and this side these two are in parallel, G3 by G2 plus 1. So automatically this summing point vanished. Here this summing point vanished. Only the finally one summing point, that is RS, and here minus, and here G4 divided by 1 plus G4 H1. Okay. Now these three blocks are what? In series. So I can multiply. These three blocks are in series. Now G1 G2 G3 plus G2 divided by G2. Okay. And here G2, and one more is G4 divided by 1 plus G1 G2 H2 into bracket 1 plus G4 H1. and one more feedback element minus. So just I have multiplied, I took a LCM here, G3 plus G2 divided by G2, and here G4, and below is 1 plus G1, G2, and 1 plus G4. This G2, G2 get cancelled. And here nothing is there means what? 1. Unity feedback. Unity feedback. Now there is a final step. This is a G of S feed forward element. This is a feedback. So I will take a now finally one block diagram. This is C of S. This is R of S. Now what happened? So feed forward element G1 into bracket G3 plus G2 into G4 divided by 1 plus G1 G2 H2 into bracket 1 plus G4 H1 divided by, here 1 minus is there, so that plus once again feed forward element G1 G4 G3 plus G2 divided by 1 plus G1 G2 H2 into 1 plus G4 H1 into 1, because unity feedback, into 1. Now you take a LCM, and finally I'll write, so if I take LCM, then below get cancelled. C of S divided by R of S equal to, you take LCM, then LCM get cancelled, G1 G4 G3 plus G2 divided by 1 plus G1 G2 H2 and 1 plus G4 H1 plus G1 G4 G3 plus G2. This is a final transfer function. So sometimes we will write G1 G4 G3 plus G1 G2 G4, we can write like this, divided by the remaining multiplication 1 plus G4 H1 plus G1 G2 H2 plus G1 G2 G4 H1 H2 plus G1 G4 G3 plus G1 G2 G4. So this is the final transfer function. I hope you understand the problem. Okay. Now, next, one more problem. That is called multiple input and single output problem. How to solve multiple input and single output problem. Okay. The next problem. Next, find transfer function. Find total output. Total output. Sometimes you'll ask like this. Find total output for a below block diagram. So in this problem, he has given two inputs. Suppose this is a G1 and here R of S, and here one more input X of S. This is a plus, this is plus, this is G2 and this is C of S, and here plus, here minus H1. So in this case, what he has asked, total output. Solution. How to solve this problem? This problem, there are two inputs. I'll solve by superposition theorem. I'll consider one input, one at a time. So other output I'll make to 0. So here I'll solve by case 1. What is the case 1? Case 1, I'll consider the input is R of s, means x of s is equal to second input, I'll assume 0, and at that moment the output C of s becomes what? C1 of s. Okay, now I'll redraw the figure. I'll start from the R of s, that is plus minus Z1. Now if it is 0, this is 0, this summing point is not required, and here it is a plus, here it is a plus, so that directly what I'll do, I'll consider G2 and C of s, then here H of s, H1. Now these two blocks are in series. Okay, I'll multiply Z1, Z2. These two blocks are in series. R of s plus minus H1 of s. Now this is a minor feedback loop. This becomes C, becomes C1, C1. Now this is a minor feedback loop. What I'll do, I'll draw here. So this becomes Z1, Z2 divided by 1 minus is there, 1 plus Z1, Z2, H1, C1 of s, and here R of s. Now C1 of s divided by R of s. Sometimes he'll ask C1 of s divided by R of s and C2 of s divided by X of s. He can ask like this, both the transfer function. That is equal to Z1, Z2 divided by 1 plus Z1, Z2, H1. Suppose first output R of s equal to Z1, Z2, R of s divided by 1 plus Z1, Z2, H1. So this is equation number 1. Equation number 1. So this is a case 1. Now case 2 problem. Now it is a case 2 problem. In case 2, what I'll do, this input I make, let this equal to 0, and whatever the C of s becomes what? C2 of s. So I'll start from here, because this is 0, I'll start from here input to output. So I'll redraw like this. The input is x of s, and I'll go to output G2, then C of s. Then from C of s take a point. So I'll start from take a point. I'll go to H1. When it goes to H1, here R of s is 0, but the sign is negative. So that what I'll do, I'll take this is a minus 1. This is 0, but minus sign is there here. In the previous case, it is plus is there, so that I have not considered plus 1. Here I'll consider plus 1. Then it goes to Z1. Then after Z1, it goes to here. Plus feedback, plus feedback. Now these three blocks are in what? Series. This is Z2, C of s, C2 of s, C2 of s, X of s, plus, and here I'll write minus Z1 H1. Now it is a minor feedback loop, so that for a minor feedback loop, this is what? C2 of s, this is X of s. So here G2 divided by 1, here plus is there, so that I'll consider minus, and Z2 into minus Z1 H1. You have to remember here plus is there, so that I consider minus and the remaining term. Now C2 divided by x of s equal to g2 divided by 1 plus g1 g2 h1. This is second transfer function. So C2 of s equal to g2 x of s divided by 1 plus g1 g2 h1. This is equation 2. Now I'll add equation 1 and 2. I'll get the total output. I'll add equation 1 and 2. I'll get a C of s. So now the total output C of s equal to C1 of s superposition theorem C2 of s, that is equal to G1 G2 R of s divided by 1 plus G1 G2 H1 plus C2 of s is G2 X of s divided by 1 plus G1 G2 H1. Finally, C of s equal to 1 plus G1 G2 H1 G1 G2 R of s plus G2 X of s. This is the final output. This is the method to find the total output. Okay. I hope you understand how to solve a multiple input and single output MISO problem. How to solve the MISO problem, multiple input and single output, by using superposition theorem. Okay, I hope you understood the problem. Two problems in this lecture I solved. Thank you.